box here that'll allow you to create just a little playground file. I will put this into the example code in the repository. So we're going to choose iOS as our platform. You get a couple other platforms, including tvOS, which is obviously Apple TV. You can develop apps for Apple TV. And it's going to ask where we're going to save this. I'm going to save this into our repository here. And I'm going to create a new folder for example code. And that's just going to create a single file for me that that you can open up, like double click on it when you pull this from the repository. Double click on this and you'll get all the code. Make sure I cover everything. Okay, so this is your first introduction to Swift. Welcome. At the top here we have import UI kit, and so as we mentioned, UI kit is the package that will allow us to import UI elements. We're not going to use any UI elements in here, though we can code against that if we want to. I'm going to change this to Foundation. So Foundation is just a lower level package that allows us to have things like strings and integers and dictionaries, all that fun stuff. Okay, so if anybody's familiar with JavaScript, who here's familiar with JavaScript? Okay, good number of you. If you're not, why not? If not, then good for you, because I hate JavaScript. Okay, so number 5, var string. Let's just rename this to string because I hate variables that have 3 characters in them. So I have this variable called string, and it's equal to hello playground. And if you notice on the right-hand side, it says hello playground. That's our output. And this is why it's called a playground, because as we code, we can look at the output. We don't have to debug. We don't have to set breakpoints. We don't have to run, step over line by line to figure out the values of everything. We just do this. Var, let's say, count equals 10. Okay? And give it a second. It'll compile. Or you can hit this play button that's down here in the lower left-hand corner. I don't know if you can see that. But all you have to do is just wait a couple seconds and it'll compile and run. And so now you can see that that line equals 10. No big deal, but if we did count, and we don't have a plus plus operator in Swift, what we do have is a plus equal operator. And let's say plus equal to 5. Hit enter. Now you can see that is 15, so that's not anything magical, but you get the idea. So we can continue that onward and onward. So let's talk about the let. Yeah, go ahead. Sorry.
So is that just the straight output, or is this like what each sort of line is supposed to be?
Yeah, so when I do an assignment like 10, assign that to count, then you see on the right-hand side 10. Let me undo what I had there. So plus equal to count is 15. That's just the result of that expression.
I see. So it's not like what the code's actually saying. Or no, sorry, what the code is like if a print statement was if a print statement was in there, it wouldn't,
Yeah, good question. So if I did this, let me see what this is going to do. Oh, okay. You're going to be like, you can't do this. Let me see if I can. No. Okay, this is just like language semantics when you get deep into the language. Oftentimes what will happen is when you do an assignment like this, the assignment operator also returns the value of that so that you can reassign it. And it might work differently in Swift, but if I did like var duplicate count equals count plus equals 5. Can I do that? And then we just do print duplicate count. Oh, why is that? Okay, maybe I can't do that in Swift. Okay, I've never tried to do that, but With some languages you can do that, like if I did 5 equals, yeah, it's not letting me. That actually gives me a warning here. So if I click on the warning, variable duplicate count and inferred to have type, it's like function or whatever. So yeah, you can't do that. Yeah, do that. Good question. This is how we discover how things work and how they don't work. But cool. That answer your question?
Yeah.
Okay. Any other questions on that? Okay. So let's pretend we didn't ever need to change count. So count was always 10. We'd want to use the let variable or the keyword here. And if I try to do that same thing, plus equal to 5, I get a warning eventually. And it'll say left side of mutating operator isn't mutable. Count is a let constant. Okay, so we talked about mutability. That's why. And if you look at this little fix-it thing that comes up when I hit the little stop sign here for the error, it'll actually allow me to fix that. So let's pretend that you were coding along and maybe you didn't think you were going to edit this or mutate this variable, but you did. You needed to for whatever reason. Xcode will let you know, hey, you can't edit this. This is a constant. This is a final, right, in Java. Do you want me just to fix that for you? And you can go ahead and hit enter on that, and it changed it from a let to a var. So very, very helpful code complete for you. So my rule of thumb is to always use let unless you know you're going to change that variable. But just by habit, just use let. So okay, something like that. Then go along, and then if you realize that, yes, I actually do need to change that variable, just click on that error message that pops up and then have Xcode fix it for you. That way you don't have to scroll up or go into another wherever you have to go. Now if you notice in Swift, well maybe you don't notice because you don't see it. We don't have any source files for this one. If you're actually in a project, you would see a .swift file. We don't have any interface files and implementation files. Objective-C has a .h file for the header and a .m file for the implementation. The interface or the declarations of items go in the header, and then the implementation of those functions go in the implementation file. In Swift, just like Java, all in one file. We don't have any class in this example, but we'll get into that next class, using classes and everything. Okay, so pretty straightforward, right? Any other any questions about differences between var and let? Okay, so again, try to always use let because it's a little bit more efficient than the baggage that comes along with a var instead of a let. Okay, so you've seen me just kind of doing this JavaScript-ish thing where I do var count equals 10, and you might think that Swift is a loosely typed language or something of that nature. It is not. It is actually a strictly based, or I can't speak today.
Strongly typed?
Strongly typed, thank you. Man, okay. I need coffee or something before I have these classes. Okay, so let me say I have count, and I wanted to set that equal to, say, a string 1. And notice I'm not using semicolons at the end like most languages do. I think Swift will let me. I don't know if this is true. Maybe, okay, well, that's a different error. You can add semicolons. It just ignores it. I just do it the Swift way. But you'll see me sometimes type in a semicolon just because it's force of habit. So you can keep them or not, but the Swift way is not to have semicolons. I've added a string to count. In JavaScript, this is fine, right? It'll just recast it to a string. Swift will not. It says something of the nature, the value of string, it can't assign a string to an int. You're like, well, why is it an int? Why don't you just reassign it? This is what we call implicit declaration of our class here. If I wanted to be explicit about it, I can say this is an integer. Okay, and actually I have a bunch of other integers in here. If I hit the escape key, I can do the autocomplete, by the way. So like if I'm typing and I hit C, It'll usually come up. If I want to get rid of it, I hit escape. If I want to bring it back, I hit escape as well. All right, so we can declare a type using this syntax. So colon int, likewise colon string. And now it's telling me you can't assign an int to a string. This gives me an error, but this fixes this error. Okay, so that's how we do it. And again, if we don't declare this, Xcode and Swift will say, okay, well, you're assigning an int. It's going to be an int. But what if I wanted it to be a double? We can't do that. So if I said, let me get rid of this line real quick, and said, I want count to be 1.2. What'll happen is, once this, okay, so it'll obviously give me an error saying you just can't do that. But what I can do is typecasting. So I can set this as an int. Give that a second to compile. And it is now value of 1. Okay, and I can actually play around with this, show you that this is value 1. I can expand this, show you underneath what that value is. Okay, so I can't do that as an int. I can't set that as a double because it'll basically just give me the error. That's what it was doing in the first place. But what if I set this to 1.8? What happens? It's still 1. You didn't see it change, but it did compile and run it. So what it does is it truncates. It doesn't round it, doesn't do anything fancy. It just says, boom, you're done. It takes whatever is in that decimal point, throws it away. Okay, so how do we handle this? Well, there's a couple of ways of doing that. We can set count to be a double from the get-go, or float, of course. You want to do that. Right? And let's see what this error is now. Cannot convert a type double to type int. Okay, so that's fine. I can't do that. So actually, I can just get rid of that typecast, and it should work for us now. Perfect. Now we can see our value is 1.8. So these little windows that I opened up, I just hit this little plus over here, and I can close that. These are really, really valuable if you're trying to get a particular variable to match something, or maybe you're coding somewhere up here. Let's actually add 1.5 or 1.8 to this. Open that back up and say, well, what happens if I change this value to 15? Recompile that. Now it's 26.8. Well, that's not good enough. Let's say 65. So, this is a very trivial example, but you can see how this would be very useful in trying to get a certain value at the end of your code based on maybe some input values at the top. Okay, any questions on that? Pretty simple stuff, but all the little tiny language stuff that we deal with. Okay, so how do we deal with strings? How do we do string concatenation? String concatenation is pretty simple. We have our string here. We can actually just use the same operators, so plus equals, and I can say dot, how are you? Wait a second, and now we see hello playground, how are you? Let me just expand this out. Okay, so now we have string concatenation. Same thing. This is the really nice thing about Swift is because they're starting from scratch, we're making everything consistent, right? We don't have, if you're adding if you're adding an integer to another integer, you just use math, right? Arithmetic. When you're adding a string to a string, what happens? Well, you don't mathematically add those strings together. You concatenate them, right? But you use the same operators rather than something like PHP, or you use, a dot or something like that. And it's a weird syntax, and it's really obnoxious. And then even JavaScript sometimes has the weird syntax that you have to deal with. I'll show you some really cool stuff with strings later in the semester, but this is just how you do string concatenation. So no big deal there. Okay, and then as you notice, we have the print to print out stuff to the console if you're using a normal application. So print, we can do string here, and it just prints out the what that looks like. But also, you can't see it, but let me expand this. I was trying to show you. It has an end line character on the end of this. expand this then. There you go. Okay, so when you print, it's printing to the console, so it automatically appends a new line character. Not a big deal, but just so you know, that's why. It's not in your actual text. It's just when you use the print statement. So when you print this out to the console, it'll print it out and then make a new line. So just a little tidbit there. Okay, so let's get something interesting on the screen here. If my count is less than 10, print greater than 10. Okay, no semicolon. Else, print less than 10. And actually, let me do that again so I can show you what I'm doing. So I'm typing in print, and what you can do is instead of just going, oh boy, okay, the interface is flipping out. So I hit the escape key just to bring that menu back. So I hit escape. I'm going to hit enter actually, and this is going to give me an autocomplete so that when I start typing, it'll show me what I should be entering in here. I can enter in basically any type, a string, an integer, or some other class. So I am going to put in a string. This one was less than 10. If you know, I don't know if you can see that in the back, but these two characters at the end are grayed out. They're not actually there. If I hit the right arrow key, it'll autocomplete that and autocomplete that. And let's see if I try out a few things here. Less than 10. Yeah, so if I hit enter after that, it does not fill that in. It just creates a parentheses. So just hitting the right arrow a couple times, or command right arrow to go to the end of the line will autofill that in. Okay, so that's an if-else statement. It's pretty straightforward. Nothing out of the ordinary. I guess the Swift engineers just like that format, can improve on it. So there it is. You can see here what the execution of this if statement is. So this is an if-else statement. Well, since my count is, and let's go back up to count, my count is 76.8, then this else, or excuse me, this, oh wait, yeah, let's switch these. You guys need to catch me on these. I can't think and talk at the same time. Okay, so we have, now it's greater than 10, so that's a true statement, and we can look at that easily by saying, okay, yeah, count's 76.8. What if I change this to -1? Still, this value here is still 10.8, so that's not good enough. So let me change this. And now my if statement changes from greater than 10, which was exported or printed out here, to my first if statement, which prints out here. So again, these initial values that are way up at the top of your code, if they affect the lower end of your code, you can just look at the output on the right-hand side there and see what that is. So really nice way of kind of testing out little bits of code or doing a Swift demonstration like this. Okay, so what if I wanted to be able to change the value of count and test it against this if statement? Then we have functions, right? So I want to call this multiple times. How do we do a function? So if you start typing in fun, because functions are fun, right? It'll bring up this autocomplete, and the way that we define functions is the func keyword, so F-U-N-C, but I'm not going to type it in and then hit space. I'm just going to hit enter, and the reason I do that is because it's going to bring up the complete syntax of what functions should look like in Swift. And of course, it's going to give me an error because nothing's filled in yet. Don't worry about that right now. But it's asking me for a name. Okay, if I just start typing, it'll replace that name placeholder with what I start to type. So let me type in check count. Now that I'm done with that, what I'm going to do is hit the Control// key. And sorry, I don't have a cheat sheet of shortcuts for you. So Control/, which is right below the question mark, of course. If you hit that, it'll cycle through the next placeholder. So Control/, Control/, Control/. We'll cycle through those. So this is really, really nice because maybe I put my cursor way at the top of the screen here and I hit Control/. It'll bring me down to that next placeholder. So a little bit of Xcode tips and tricks here. So parameters, what is it looking for as a parameter? I'm going to ask it to bring in my count variable, but since these are local variables, it doesn't really matter what I count this as, what I call it. So I'm going to call it, actually I'm going to call it a local count. Okay, and is anybody Pascal fans in here, or no? Not Pascal. Fortran. I think Fortran. I don't know. So there's another language that does an arrow for the return type, but the arrow signifies the return type, so we have to give it a return type. I'm just going to put a Boolean in here. With all classes, every class is a capitalized letter, or capitalized word. So bool is capital bool. Int, if you saw me do int, was capital. Double is capital. These are not basic types. Basic types are a carryover from C. It's back in the day when you wanted to have like 2 bits, right? 2 bits represent an integer or something like that, or a character object, or a character would be 1 bit. These are all objects, okay? So this is very similar to the way that Java does objects. Even though Java has basic types, there are no basic types in Swift in the traditional sense. Okay, so this double actually has, if I do count and then do dot notation, I have a bunch of functions attached to that double, right? This would never happen in Java or C, C++, any other language. You can't call some integer or double dot. And there's not that many methods on here, but you can do things like is 0, that's a function, and that'll return a Boolean. Or maybe. Oh, I'm sorry. That's not a function. It's just a Boolean. It's a member of that class or that object.
Is that a property or?
Yeah, it's a property. Thank you. Yeah. Right. Trying to switch between Swift Lingual and Java, and yes, property. Thank you. Sometimes I'll say methods. Sometimes I'll say functions. Sometimes I'll say routine. Yeah, I use them all interchangeably. So sorry about that. But okay, so where were we? So I have my return type, so control / brings me to my function body, and hopefully I didn't, yeah, okay. So I just pasted that back in what I cut out of there, and so now we have this, and it's going to give me an error because I don't actually have a return type. So in here, I'm going to say if it's less than 10, I'll return true on that one, and return false here. With Objective-C, which I'm kind of sorry they got rid of in Swift, though I think maybe it still exists, I'm not sure. But I know the Swift way is to use true and false. In Objective-C, they used yes and no. And that actually made more sense when you're programming and you're reading your code. Is this 0? Yes, it is 0. No, it's not 0, right? That's how we naturally speak. If somebody said, is this 0? And they said false. Like, what? False it is 0, or false it is, I don't know. It just, a little carryover from Objective-C, but I do believe, let's see if they even have, yeah, they don't have it anymore. You can get it back by like declaring a variable or a global. Yeah, I have a lot of baggage. Been doing this a long time. I've been programming Objective-C since 2003-ish, so 13 years with Objective-C. I'm sad to see it go. But with any good programmer, at least I like to think I'm a good programmer, you got to learn the newest and greatest things, and that's Swift in my opinion. So Objective-C, they are eventually going to deprecate from the library. But right now they're actually they're equal citizens, they're first-class citizens. Okay, so yeah, rambling needs to stop because we need to finish up one more thing. Let's see. Oh, okay. I didn't name this parameter, or I didn't give it a type, so I have to give this a type. This needs to be a double. Okay, so that's what we do. It's again the same as you declare variables. Just make sure that you have the type there. What it was asking me, it's kind of a red herring, but what it was telling me when I had this error message is unnamed parameter must be written with the empty name underline. We won't get into that exactly, but it's just letting me know that I didn't, well, what the real problem is I don't have a type for it. So let me hit escape, hit colon, do double, and there we go. Okay, so save that, and okay, so that's going to be fine. I'm not calling this function yet, so let me call this down here. Check count and pass it 10. You can see the output there. Oh, okay. And okay, so this is just a couple examples of that, and
I believe you need to use local count in your actual function. You named it in the parameter and then in the actual code.
thank you. I ran through this code before class just to test if everything that I thought was true is still true, but again, it's hard to think and code at the same time. So yeah, if you see that, just call it out. Okay, so great, thank you. So that fixes that. We have false, false, and 4. So if anything is less than 10, 10 is not less than 10. So that's false, right? No. What am I doing? So if local count is less than 10, which is so yeah, okay, that's right. So it executes this line, executes this line. We can actually look at that. Because this is being called multiple times, false, false. Yeah, you can see the output of those different calls. Okay, one more thing I want to show you before the end of class. While count is greater than 10. Okay, so basic while loop, so hopefully a lot of the stuff you know in Java already carries over. Let's say count is plus, well, let's do multiplied by itself 1.2. It's a, and I jumped ahead of myself. Let me change this back to an integer. Let's get rid of that real quick. Change this to an int. Get rid of that. Actually, instead of getting rid of that, I'm going to hit command / and that's going to comment that out. Let's do that. And okay, so obviously this is not going to allow me to do this. If I was going to change this, what would happen is it would actually multiply it by, let me set count equal to 0 first, like you probably normally would. And you switch that. Okay, so now we have an infinite loop. That's what I was trying to get at. We have an infinite loop. It's going on forever and ever and ever. And you're like, why? Well, it's because count is 0, and anything multiplied by 0 obviously is 0. So I could try changing these all day long, and it won't work. So if you ever see that kind of thing where these things are just spinning up, it's an infinite loop, and it's doing it in real time. Okay, so let me change that. Let me go back to it being a double so I can show you something cool. Okay, and let's see, count is less than 100. Actually, let's do 1,000. Okay, so this ran 26 times, so it's kind of cool to see how many times this while loop ran. Because I'm multiplying by itself and 1.2, it's going to be a nonlinear growth, right? It's not going to be just a straight line. And I can look at that if I go to this plus sign way over there on the right, hit the plus, I can actually see a graph of how that variable changes over time in that loop. So some really cool things. And so you can see that the growth is very, very flat at the beginning, and then kind of as it goes toward the, it ran 26 times. So if you just kind of look at these, maybe on the 20th time it starts to get higher. And so maybe that growth is not good enough for you. Maybe you want 1.6. Instead of running 26 times, it runs 10 times. And you did see kind of a ghost image of what it used to look like to this image. And so you can play around with these numbers and say, okay, 1.3. Okay, that looks pretty good. Maybe that's what you want. Maybe a little bit shorter. And there you go. So really, really cool ways of playing around with that. And I believe that is all I wanted to cover today on Swift. So make sure you read the book. I don't know at what point you should be up to, but just try to get through it. Read through the interesting parts. Definitely like loops and if statements, class decorations, function decorations, return types, all that fun stuff. Just get the basics. And as we start developing apps here in class, we'll go through some of those language kind of that syntax, that grammar, and just throw some real small little tips and tricks. And hey, if you do it this way, it works that way. It's kind of hard. I don't want to just spend like 4 weeks on just Swift because it's really boring. I want to get you into iOS development. So that's where we'll be, and we'll start up the same thing next class. Thanks for coming out. I'll see you next Monday.